Alright, so today we're going to look at solving radical equations, and this is question number 5 on lesson 10. We're asked to solve the square root of 2x minus 4 equal to x minus 2, and anytime there's a square root that's isolated, let's think getting rid of the square root. So we're going to square both sides, and when we square both sides, the square root goes away and you're just left with the stuff inside the square root. And on the other side you have x minus 2, but remember x minus 2 squared is telling you to do x minus 2 two times. So we'll carry this down, and then on the right side we're going to distribute everything across. X times x is x squared, x times negative 2 is minus 2x, negative 2 times x is minus 2x, and negative 2 times negative 2 is positive 4. So now, since you have an x squared term and an x term, we're going to look at making one side 0 and seeing if we can factor it. So before we do that though, let's combine our like terms. The negative 2x and the negative 2x can combine into negative 4x. And now let's make this side 0, so we'll subtract 2x, which means it goes on the other side, and we'll add 4 to both sides, and so you have 0 equal to x squared. Negative 4x minus 2x is negative 6x, and then 4 plus 4 is 8. So now that we have 0, we can try to see if it's factorable. So let's make a t-chart. Can you find a number that multiplies to 8 and at the same time adds to negative 6? And the two numbers that can do that are negative 4 and negative 2, because negative 4 minus 2 is negative 6. So that means we can rewrite this as x minus 4 and x minus 2. And then your solutions are what makes each binomial equal to 0. So in this case, 4 minus 4 is 0. So x has to be 4. And then 2 minus 2 is 0. So my other solution is 2. The thing we got to be aware of though is these are possible solutions, because sometimes if you have an x outside a square root and another x inside the square root, we could be introducing an extraneous solution, which is actually not going to make the equation true. So we have to check to make sure that there's no extraneous solutions by putting in 4 back into the original equation and then doing the same thing with 2. So we'll take the square root of 2, since we got a 2 in the original one, x. We'll put in 4 minus 4. And on the right side for x, we're going to put in 4 and then minus 2. So let's simplify it a little bit. The square root of 2 times 4, 8 minus 4 is 4, is equal to 4 minus 2. Square root of 4 is 2. 4 minus 2 is also 2. So that's true, which confirms that 4 is an answer that works. And then let's do the same thing with positive 2. So we'll do the square root of 2 times positive 2 minus 4 equal to 2 minus 2. So the square root of 2 times 2 is 4, minus 4 is 0. 2 minus 2 is 0. So the square root of 0 is still 0, and 0 is equal to 0, which is also true, which means in this equation there isn't any extraneous solutions. Both 4 and 2 are valid. Okay, another one I'd like to look at is question number 6, because there might be a tricky part to this one, but let's kind of do the same process. Let's get the square root by itself by subtracting 1. So then we'll do square root of x plus 1 equal to x minus 1. Let's square both sides, which gives me x plus 1 equal to x minus 1 and x minus 1. And so we'll distribute that out on the right side, which is going to be x squared minus x or 1x plus 1. Combine your like terms. Negative x minus x is negative 2x plus 1. And then we'll get the left side to be 0. Subtract x, subtract 1. So we get x squared minus 3x. And then the weird part I mentioned earlier might come in where you have 1 minus 1, that's 0. So that means that constant term goes away, or it's just 0. But you could still factor it, because if you have the x in both terms, remember we can factor out the x. So if you have x squared and you factor out an x, you have just x left. And then if you factor out an x from the 3x, you have 3 left. So I have two solutions here. If I was to ignore the x minus 3, what would make this x 0? Well, it would be 0. So 0 is one of my possible solutions. And my other possible solution would be positive 3. Now let's check again whether both of those solutions or any of those solutions work. We'll put 0 back into the original equation. Let's do it over here. So we'll do the square root of 0 plus 1 equal to 0 minus 1. Square root of 0 plus 1 is 1 plus 1, which is negative 1. Square root of 1 is 1, so this is going to end up being 2 equal to negative 1, which is not true. So we know that 0 is not a valid solution. Let's check for 3, and if 3 is not a solution, that means this problem has no solutions. So we'll do the square root of 3 plus 1 equal to 3 minus 1. Square root of 3 plus 1 is 4 plus 1. 3 minus 1, which is 2 plus 1. 3 minus 1 is 2. 2 plus 1 is 3. And you end up with 3 equal to 2. So if 3, I'm just looking over my work, and since 3 equal 2 is not true either, it means that 3 is not a solution as well, which means this problem is going to end up with no solution. Alright, hopefully this helps. And as in terms of radical equations in Algebra 2, this is the most we're going to go. So practice and get good.